Welcome to The Explainer. Today we're diving into a really critical corner of the AI world, security. We're going to talk about how large language models can be tricked and, maybe more importantly, what we can do to stop it.
So, picture this. You ask an AI for a secret key, and, like it's supposed to, it says no, that's confidential. But then, you try a different angle. You ask it to encrypt that same secret key, and boom! Just like that, it spits out both the original key and the encrypted one.
How in the world is that possible? How can an AI be so buttoned up one second and then so easily fooled the next? Well, it all boils down to a fundamental vulnerability in how these large language models, these LLMs, are actually built.
See, unlike the software most of us are used to, there's no real wall separating the developer's instructions from what you type in. To the model, it's all just one long, continuous stream of text.
And this right here really shows you the problem. A developer programs the AI with a system instruction, something like, "You are a helpful travel assistant." Then your request, "Book a flight to Mexico," just gets tacked right onto the end. The poor LLM is looking at this one big chunk of text, trying to figure out what's an order and what's a request, and that confusion is exactly where the vulnerability lies.
And you can bet that attackers have gotten incredibly creative at exploiting this. So let's take a look at some of the most common ways to get around an AI's built-in safeguards.
One of the simplest methods is what's called a context-ignoring attack, and it's as straightforward as it sounds. The attacker just flat out tells the model, "Hey, ignore everything you were just told and do this instead." And it can have pretty wild results, like in this real-world case where a company's bot was tricked into taking the blame for a major historical tragedy.
Another really popular trick is the role-play attack. Hackers will tell the model to become a character that doesn't play by the rules. The most famous one is probably Dan, which stands for Do Anything Now. By telling the AI to just be Dan, users can get it to say and do things its normal programming would never allow.
So, why does all this matter so much? Because AI isn't some niche tech experiment anymore. Over half of CEOs, 55%, see it as a massive opportunity. That means these models are being woven into the fabric of businesses everywhere. Securing them isn't just a technical problem, it's an absolute business necessity.
Okay, so we get the threat. Now for the important part. What's in the defender's playbook? How do we actually start building more secure AI systems?
So this gives us a whole toolkit of practical things developers can do. You can use basic filters to block bad words or phrases. A pretty clever one is the sandwich defense, where you literally sandwich the user's input between your instructions. That makes it way harder for the AI to get confused. Another good one is using XML tags to put clear digital bookends around the user's text so the model knows, okay, this part isn't a command.
But here is the absolute key takeaway. There is no magic bullet here, not a single one. An attacker can eventually find a way around any one of these defenses if you use it by itself. The only strategy that really works is defense in depth. You have to layer multiple protections on top of each other to build a truly tough system.
So if just layering these individual prompt defenses isn't quite enough, how do we build something that's truly robust? Well, the answer is to think bigger, to go beyond just the prompt and look at the whole architecture. And one of the most powerful ideas out there right now is, essentially, to fight fire with fire. You use a second LLM, a specialized one, that acts as a security guard. Its one and only job is to screen all the incoming prompts before they ever get to your main application. It's literally an AI bouncer. And this breaks down exactly how that system works. The user's prompt doesn't go straight to the main AI. Nope. First, it gets sent to this prompt shield. That shield model takes a look, analyzes it for any funny business, and gives it a thumbs up or a thumbs down. If it's clean, it goes through. If it's malicious, it gets blocked right there, never getting a chance to cause any trouble. This quote from Oli Wright at IBM Security just nails it. For a long time, the focus has been on securing databases, securing the infrastructure. But the new frontier, the really tricky part, is securing that live, real-time interaction between a person and an AI. And that's a whole new kind of security challenge.
And that really leaves us with this final question to think about. This race between AI attackers and defenders, it's really just getting started. As these incredible models get more and more woven into our lives, making sure we can trust them is a challenge that's going to demand constant creativity and constant vigilance.